so you can refer back to it if you need to. All right. So for this first question, when you hear the word solution, what things come to mind? Unless you hand or I have an answer like we did the other day. Erin? Like an answer, what the equation ends up being. Anyone have a different opinion? The answer to a problem. So you guys kind of had similar. So I'll write that. We can also kind of think about that answer as it makes the equation true. So the other day we were trying to do true statements, and I forgot about the last page of what we were doing last time. If we have time at the end, we'll go back and do that. But the true statement thing, those kind of tie in together. But if we were given, or let's say we solved a problem and we got a solution, how do we know if those are actually the solutions or not? How could we determine that? Go ahead. We put 5 back in for x, simplify this, and see do we get a true statement or not. That would tell us this worked or it didn't work. So 13, I'm going to put, anytime we put something back in, we're going to use parentheses or try to. So 13 times 5 minus 7 equals 58. Did I give you guys calculator numbers last time? No, I was going to, and then I think we ran out of time. So let me do that really fast, and then if you want to grab. All right, 13 times 5 would be what? You guys can say this out loud. 65. If we subtracted 7, would we get 58? Yes. So then this is a true statement. 58 equals 58. Because this is a true statement, we can say, yes, this is a solution. So this is a really good way to, when we actually start solving, you get an answer. It could be the right answer, but to check yourself, you could put that answer back in, double check and see, did I do this correctly or not? Sometimes you may forget a negative or add or subtract the wrong thing, and this is a really good way to check yourself. Now, for number 2, we already determined what the solution to this is, so the negative 5 is probably not going to be a solution, but let's check it anyway. So we're going to multiply 13 and negative 5 now, so now we'll have negative 65. And that would give us what? Negative 72, 58 on the other side. Is this a true statement? No. These do not equal each other. Negative 72 does not equal 58. So this is not the solution. So that would be a really good way to check yourself. You put something in and you don't get the same thing at the end. Uh-oh, I did something wrong. And you got to go back and figure out what that is. Right? Questions on how to determine if something is or is not a solution?
When you start finding the actual answers and you put your solution on there, you might start noticing that we're going to be circling or boxing out our answer. We're not getting into that habit. Because it will make it much easier for us to see what your answer is.
Yes. I want you guys to try 3 and 4. You can work with the people at your table, and then we'll come back and we'll discuss, are these solutions or are they not? So I'll give you a couple minutes to do that. And this is or is not a solution?
No.
It is not. Did anyone need to see this one work out? I don't see any yeses. Did not hear any yeses. What about number 4? Was this or was this not a solution? Does anyone need to see this one worked out? Okay, for this one, we had to put negative 34 over 2. And then order of operations, we need to divide first, so negative 17. And then add negative 17 and 5, and that would give us negative 12. Negative 12 equals negative 12, so that would be a true statement, so this would be a solution. Okay. Questions on 3 or 4 before we move on? If at any point I'm going too fast or you miss something, just let me know. I can go back. I can try to slow down. On the next page, we're going to go through some of these. So these problems are solved already. We are going back to remember or practice properties of equality. What are they doing? And we're going to use these properties. Addition, subtraction, multiplication, and division, property of equality. That means it's being done to both sides. And then the distributive property, where you usually have parentheses. So we're going to start with number 1. I'm sure, because they do a lot of similar things. So if we're starting here, this is our given statement. From this to step 2, what changed or what did they do? And let's do hands or I have an answer. Aaron?
They distributed the 2.
They distributed the 2 to the x and the negative 9, so that's our distributive property.
Can you kindly abbreviate?
Oh yes. After this, I'm going to start abbreviating because it'd be too much writing for me.
Thank you, because I have messy handwriting.
I'm trying. Right, so they distributed. Subtract what?
Subtract 18.
Now
Well, add.
add. There we go. So they added 18 to both sides in this next step to get positive 8. So that would be our addition property of equality. I'm going to shorten that to POE, property of equality.
Division.
And then that last one would be division. We divided both sides by 2 to get 4. So when we get into solving, we're going to be using these properties, but right now we're just trying to identify what properties were used. Do you have any questions on this first one? We're going to jump down and do number 3 together. Does anyone still need this before I scroll down? Yeah. Sometimes I go too fast. Just let me know.
I like to imagine that like I'm teaching somebody while I'm also working myself. So it's like you're just describing the instructions to somebody else. It's easy to think of it like that.
Right. For number 3, we're looking at this equation. And then from here to here, again, hands or I have an answer, what changed? And I see yours, I just want to make sure because you were just answering that no one else had an answer. And what did they multiply?
They multiplied 7 times
Times the 2. So this 2 that was being divided, they multiplied 2 on both sides. These 2 canceled each other out, became 1. And then on the other side, that's how we got 14. So multiplication, property of equality. Am I good?
For number, for the third one, on is, I actually, that's it's, I have the one for 4.
That's fine. We can Tell me that one and then we'll go back.
DDPO.
The division property. Yes. So
That's
that
how I'm going to be reading, just like first letter.
yes. Because here we're dividing both sides by 5, so okay. And I see one answer here. Go ahead. Look at 3.
Addition.
Addition again. So this was similar to the first one we just did. And a lot of problems are like that. Sometimes there's subtraction instead of addition. Most of our problems we divide at the end. The only time that's really not the case is if we were already dividing and we would multiply. Okay. Questions on this one? I want you to just take like a minute, maybe a little longer, and do this second one. Alright, I'm going to put the answers up here, and then we'll talk about if you agree or not, and what you may have had. So this one should be subtraction property of equality. And then our last one should be multiplication property of equality. No, I hear a lot of erasing. Who had addition instead of subtraction? I did see that a few times. That's okay. Because here we're already adding, and I think that may have been why you did that. But we have to think about what did they do to move that 10? And to move that 10, we would have to do the opposite and subtract. Questions on number 2? Go ahead and go to the last page. Okay. So this question is kind of like going back to the first question I asked about what is a solution. In order to get a solution, we have to solve the equation. We have to use inverse operations to get something that would make the equation true. So I'm going to say find a solution that would make the equation true. You could be even more specific and say, make the equation true by using inverse operations. We're going to leave that as an implied. Now, if I asked you what is the inverse or the opposite, or how do we undo addition, what would we say? Subtraction. We can say these out loud. I'm just going to draw arrows. What about division? How would we undo, or what is the inverse to that? Multiplication. Multiplication.
Square would be cube or square.
It'd be square root. So if we had something that's square, the opposite would be a square root. So like if I thought of 2 squared is 4. If I took the square root of 4, we'd get 2. So they undo each other, they cancel each other out. And then cube and cube root would be the same thing. So like 3, yeah. So 2 to the 3rd power is 8. This is 2 times 2 times 2, the last 2.
That didn't seem like, why did that not?
Because it's 2 times 2 times 2. But if we took the cube root of 8, that would be what times itself 3 times would give us 8, and that would be 2. So they undo each other. Take a second, read this, either up here or on your paper. These are good guidelines if you get to a problem and you're like, I don't really know where to start. For the most part, these work for just about all problems. There are some that they don't apply to. If they have parentheses, distribute. If they don't, move to the next step. If they have like terms, so more than one thing has the same variable, or more than one thing doesn't have a variable, you could start combining those. If they don't have those, then our goal is to try to get the variable by itself. So we're going to be moving things to the other side, adding, subtracting, and then trying to get the variable by itself by multiplying or dividing. So I want you to look at these 10 problems, and of those 10, which ones look challenging, or you may not know how to start, or you just want to see work out or do together. So take a second look at those, and then if you have any, you can raise your hand. I'll circle them, and then we'll go through those together. Am I good?
9.
9. Any others? We got 9, we got 10. Any others? 6. 6 is a good one. Any others that we want to see or go over?
I'm going to say number 3.
So we will start with those, and if you see another one that, can we also do this one if we have time? Yeah, okay. We'll start with 3 and then go down. I like showing multiple ways to do things because there's usually more than one way to do things. I was going to say the same, but it's probably not the same. One would be to deal with the fraction. One would be to get rid of the fraction. So if we were to deal with the fraction, we're going to leave it as is. And we need to get rid of everything that's around p. So we need to get rid of this 25. We need to get rid of this 2/3. We'll deal with the 2/3 here in a second. We need to get rid of the 25. How would we do that? Adding 25 to the other side because it's subtracting. We have 2/3 p equals 1/4. How, before I solve it, how would you have gotten rid of this 2/3? What would you have done next? Okay, so that is one way. Not an incorrect way, it's just sometimes if you don't put it in the calculator correctly, it gets messy. Dividing both sides by 2/3 because these are multiplying, and to undo multiplication, you have to divide. So one thing you could think about doing is dividing it. Now you could do this in your calculator, but again, it gets messy. But I'll show you how to do that. Okay. So on your home screen, if you go into, I haven't used a calculator all year, or for some months. Nope, not that one. Not that one either. Paula's fault, I remember. Alpha, what equals 50? Alright. Alpha, green button. I think it's green on yours.
Yes.
And then y equals. It's the little green one at the top. That will give you a little menu that has fractions in it. We want this first one, the n over e, numerator over denominator. And it will give you fraction bars. And what you're going to do is, since we had 140, you can put that in here. But then we had another fraction, so I just hit the down arrow. And then I'm going to add in another fraction here, alpha y equals. And add in another fraction and do my 2/3. Now usually when we divide, we get smaller numbers, but we got a bigger number. I'm going to explain why or show why here in a second. Our answer is 210. If you were doing this by hand, instead of dividing by fractions, so in math, we don't really like dividing by fractions because it gets messy. So instead of doing that, I'm going to rewrite this off to the side. What the calculator is really doing when you divide by fractions is it's taking this fraction, it's flipping said fraction, and multiplying by that flipped fraction. That's called a reciprocal, and it's doing that on both sides. That's why we get a bigger number instead of a smaller number when we're dividing by fractions. So these would cancel, become 1, and this would become, and you could multiply fractions in your calculator the same way we divided. I want to do that really quickly. So if I put in 140 and I multiply, I need to go back and grab my fraction, alpha y equals. But now it's no longer 2/3, it's 3/2. And it'll give me 2/10. So anytime you're dividing by a fraction, you're really multiplying by the reciprocal. Right? So that would be dealing with the fraction. Questions on that method? You do not need to write this second method unless you so choose. But I'm going to show you the other method. Sometimes we see fractions and we freak out. This is a way to not do that. If you still needed that, I will go back. I just need to rewrite. What it was. Thank you. Alright, if we wanted to get rid of the fraction altogether, we could multiply the entire equation by something that would make this not a fraction. Usually we have to look at the denominator, so this has to be some multiple of 3, that way it gets rid of the 3 in the denominator. 3 works. We're going to multiply this entire side by 3. But what we do to one side, we have to do to the other, that multiplication property of equality. So we also have to multiply the other side by 3. If we multiplied 3 and 2/3, this would become just 2. Now, I did that in my head, and I probably shouldn't. Let's backtrack. If I was multiplying this out by hand, you could also do this in your calculator. All whole numbers are really fractions written over 1. So all of the numbers you know really have an invisible 1 underneath. And we're multiplying across. So this will be 6 over 3. And then we could simplify this to become 2. Now again, do you have to do that by hand? No, you can do it in your calculator, but so you know where that came from. 3 times our negative 25 would give us negative 75, and 115 times 3 would be 345. Someone to check that for me. Okay. Sometimes I'm not confident with that stuff. I should be more confident. Okay. And then we would solve it just like normal. But now we don't have any fractions. They're just bigger numbers. So if you would rather have the fraction and not bigger numbers, then do the first method. If you don't care that they're bigger numbers and you're glad that the fraction is gone, then you can do it this way. So we would solve it just like we did before. What is that for? Someone did that for me. No, 3.
Yeah, that would make more sense because our answer was 2 times.
Even though we did it a completely different way, we still get the same answer. As long as mathematically your work makes sense, I don't care how you do it.
It is really important to make sure you guys show your process, because if you just slam in the answer there and there's no proof how you got there, we're not going to know if you fully understand the method that you're using.
Right. Do you have any questions on this one? We're going to have time for one more and then we'll stop there. And we will leave number 6 for next time. We're going to do number 9. For number 9, what do you think our first step is? Distribute. We have parentheses, we have a number outside of said parentheses, so we need to multiply to everything inside those parentheses. And then everything else we're going to keep bringing down. So 4m just gets brought down. Negative 5 times 3m becomes negative 15m. Negative 5 times positive 10 would become negative 50. In our little chart, next was combine like terms. Do we have any like terms?
The 2m.
Yes.
So we got the 4m, we got the negative 50.
So if we combine those, we're not doing opposite when we combine. We're doing whatever it says. So here it says 4m minus 15. We're going to do exactly that. So negative 11m. The only time we do opposite or inverse operation is if we're moving something to the other side. And now we can solve this like a normal problem. What would be our next step? At 50.
Do the outside as well, right?
176. And then our last step. Divided by negative 11. Negative 16. So if we were to put this back into the original, with all of the m's, we have to do it twice, we should get negative 16.
Yep. And while you're checking your work, it doesn't hurt to plug it in. I usually say this in my English classes too. I'm like, check yourself before you write yourself. So
That works. Alright. And then we have like 8-ish minutes. We're going to save 10 and 6 for next time. We have practice problems on the back as well as others we did not circle. If you want to practice more, this is not a homework thing, but if you want to practice more, you're welcome to. And then we'll continue that